Welcome to this video presentation. So here we are going to talk about some special numbers. In this video I have included three of them. Uh, so we shall start with 142857. There is something called as cyclic number. So cyclic number is a kind of unique number, special number, where if I multiply that number, so let's say the the given cyclic number is a 5-digit number. All right, so if I multiply that whatever the number is, if I multiply that number by, let's say, 2 or 3 all the way up to 5, all right, all the way up to 5, that is the number of digit of that number. So if I multiply that number with any of the numbers from 2 to 5, I will get a number which is some permutation of the digits of the original number. So it may sound weird or strange, so let me show some examples. Okay, so here if I multiply 142857 so if I multiply this 142857 with 2, I get 285714. And if you can notice that, then you'll find that this this very number, this new number, which has been obtained by multiplying 2 with our required number, or the cyclic number. If I multiply 2 with that number, I will get some permutation of its digit. So it's not something new. It would have been new if it had some other digits. Let's say 1, 3, 4, 5, 6, 8. Let's say I would have got let's say I get this particular number. All right, if I get this particular number, which is 1, 3, 4, 5, 6, 8, on multiplying this number with 2, then I would say this very number is not cyclic. All right, this number is not cyclic, simply because this particular number, which has been obtained by multiplying 2 with this number, is not a permutation of the digits of this number. Alright, here we have 3, but we don't have 3 in this particular number. However, in this number, that is 285714, what we find is all the digits in this number are simply obtained from this number. So they are some sort of different arrangement other than this number. So in that sense, this number is called cyclic. As it is cyclic in nature, the number keeps repeating based on its permutation. So in that sense, we call it cyclic. So another example here, 142857 into 3, this equals 428571, which is again another rearrangement of the digits. You can distinctly see that it does not contain any digit apart from what we have here, that is 142857. Similarly, in this case, we have the same situation. If we multiply this number by 4, so if we multiply this number by 4, we get 571428, which is again another permutation of this number. We have 5, we have 7, we have 1, we have 4, we have 2 and 8, which are again included in this number. So in the same way, we have this example and this example. Both show the same situation. However, if I multiply this number, so if I multiply this number, which is 1 4 2 8 5 7, if I multiply this number, alright, if I multiply this number with, let's say, 7 or 8, then the resultant number won't be the permutation of this particular number. It won't be the permutation of the digits of this particular number. So to demonstrate, let's see what is the resultant number right here. So if I multiply 142857 by 7, I will get, I get 9 9 9 9 and 2 more 9. Alright, so as we can see, every number in every digit in this number is different from the digits of this number. Also, or simply you can say that this particular number obtained by multiplying 7 with this number is not the permutation of digits of this number. We don't have 1, we don't have 4, we don't have 2, 8, 5 or 7. So cyclic numbers show the permutation of its digit only when multiplied by the numbers all the way up to 1 to its number of digit, which was 6 in this case. So we have multiplied with 6. That's all. And this is the smallest such number. So if we look for the next cyclic number, well, I don't remember now, but it would be definitely larger than this. Anyway, so next we have 1729, which is also a unique number. It is also called a taxi cab number. So there is a famous story behind this, and the story goes like this. Indian mathematician Ramanujan was sick, and he was just laying on the bed in a hospital, and his mentor or colleague G.S. Hardy went to see him, and he was just getting out of a taxi, and he felt some sort of awkwardness or dislike towards the taxi cab number, which was 1729. So after he reached the hospital, he reported that incident to Ramanujan, and instantly Ramanujan said that, well, that's not a boring number, or that's not a number that you should dislike, because it's the smallest number expressible as a sum of two squares in two different ways, and even mention the examples like it is equal to 10 cube plus 9 cube and 1 cube plus 12 cube. So hearing that, Hardy was really shocked, and I think he even asked what is smallest such number which is expressible as a sum of two cubes in two different ways. So So I think Ramanujan told that uh, he he don't he can't say the exact number, but the first such number uh, should be a huge number, not as 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 small as 1729. So in in this way can it can popularity. So what I wanted to tell is this particular number was already known to him while he was in India. So maybe while he was 20, or so maybe while he was in his 20s in India, he he has uh, he had worked on those numbers in his second notebook, I think. So Ramanujan had three notebooks: first, second, and third. I think third was lost, and later they found out. So there is a whole theory of these kind of numbers. There are certain general formulae which which can be used to generate a whole family of such numbers. Uh, so that's all for this video. Thank you.